The 10 kilogram collar A, which is connected to a spring, is pulled from rest in the position shown and is sliding with negligible friction up the fixed rod, inclined at theta equals 30 degrees, under the action of a constant force P, 500 Newton, applied to the cable. Knowing that the spring is initially unstretched, with K equals 200 Newton per meter, determine after the block has moved 120 centimeters up the incline. A, the work done by the constant force P. B, the velocity of the collar. And C, the force exerted by the rod on the roller. There is a collar here attached to a spring. So if it is pulled, the collar will move to the left, but the spring will give a resistance. The friction negligible, so no friction. The kinetic energy at position 1 is 0 because it is at rest. Kinetic energy 2, it has moved 120 centimeters. The collar will be at B. At B, the cable is no longer formed this angle. The cable becoming 90 degrees. This angle is not constant. To calculate the work due to this force P, you cannot using this angle because the angle keeps changing. To calculate the work done by the force P, I need to see this part. Suppose this is point E. When you pull the cable will extend in this part. So knowing the extension, that is the displacement. So that is the length of cable AC, 1.5 meter. The length of cable BC is 90 centimeter. The difference between LAC to LBC will represent the displacement of this part, point E. 0.6 meter. So knowing the displacement, which is parallel to the force P, you can calculate the work, E times displacement. That is the work done by the constant force P. Now let's go to question B. The velocity of the collar at B. For that, let's draw the free body diagram. I draw here two free body diagrams. One is at A, one is at B. Because the force P changed from the cable point of view. That is the direction of displacement. That is perpendicular to the displacement. That is the direction of P when the collar is at A, and then this is the direction of P when collar at B. And the weight remains the same, vertically downward. P is the tension of the cable. I assume that there is no friction at the pulley C. If there is friction at the pulley C, the tension in this cable is no longer P. So if the weight forms an angle theta to the perpendicular to the rod, we have the component perpendicular W cos theta. Then we have the component parallel to the rod, W sin theta. That is the normal, the reaction from the rod to the collar. In the direction perpendicular to the collar, it is in equilibrium. So the sum of all forces perpendicular in this direction equals to 0. Usually we calculate N because we want to calculate the friction. However, in this case, it's stated negligible friction. Then we have the force from the spring, Fs, directed toward the spring, because the spring is extended now. So it will pull back the collar. These are all the forces applied to the collar at A and at B. From here, you need to obtain the work produced by each force. The work produced by force P, you have answered it in question A. assume the displacement positive is going up to the left. So everything in the same direction will be positive, everything in the opposite direction will be negative. Work done by the force P that you have calculated in question A, 300 joule, and then you have the work done by the weight. We are interested to the component parallel to the displacement, W sine theta. We have negative here. We have the value, negative 58.86 joule. Then we calculate the work done by the spring. The spring is going to the right downward, opposite to the direction of displacement. So we have the work negative. So you have the work done by the spring, negative 144 joule. Total work, you sum up all the works produced previously. Not to forget the work from the force P. So you have the total of 97.14 joule. And then the kinetic energy of the color A, you know it is at rest, so it is 0. And then at B, you don't know the velocity. You write the work and energy principle. So you have the velocity at B. Question C. What is the force exerted by the rod on the roller at B? At B, this is the free body diagram. The force exerted by the rod on the roller B is N. To obtain N, you try to find all the forces perpendicular to the rod. Assuming positive upward here, you have N plus P minus W cosine theta. So you have N plus P equal to W cosine theta. You have the value of N. After you calculate, you obtain negative value of N. The real direction of the normal is downward.